Welcome, everyone. This is Michael Gibbs, and welcome back to our Cisco Certified Network Associate training, our completely free CCNA 200-301 course. So the Cisco Certified Network Associate, or the CCNA 200-301, is considered the de facto industry standard for Intro to Networking, and it's the Cisco system's primary Intro to Networking certification. And today we're here because we are running a completely free CCNA bootcamp. We will cover some Cisco networking essentials, and this is network engineer training, network administrator training, or if you're like me and you're working in cloud computing, this is networking for cloud computing, and these are critical cloud computing technical skills. And if you're a cloud architect, these are critical cloud architect skills. And that's why we're doing this Cisco certification training completely free. Whether it's a CCNA for beginners or free network training, or whether you want to think about what is a computer network or networking and cloud computing, that's why we're here with this Intro to Networking course, because we want you all to have the best careers. And whether you want to be a network architect, a cloud architect, an enterprise architect, a solution architect, a network administrator, a network engineer, we've got to know the network and the data center, truthfully. But, today we're talking about networking, and we're super happy to do so. So, before we begin, let's let you know, I want you to know a little bit about the format. We'll be going for approximately 3 hours today. Then we're going to have a nice, relaxing weekend. And then next week on Tuesday, we're going to start back up 3 hours per day to get all of you cloud hired, network hired, or anything that you want. So I'm so glad that you're back here today. So let's keep it up. Just letting you know, if you've just joined here and you're trying to get your first cloud architect job, please sign up for one of our cloud architect webinars. How to get your first cloud architect job. They are completely free. And to let you know, we try to come out 2-3 times a week on YouTube Live to answer any kind of cloud architect, cloud computing questions you may have to build the best career. So let you know that. And also, if you're looking to get AWS certified, we have a completely free AWS Certified Solution Architect Associate course on our website. If you're looking to take the AWS Advanced Networking, guess what? We have a completely free course for that on our website. And now we have this completely free CCNA course on our website. So go out there and get any job you want. If you haven't read it yet and you're interested in cloud computing, we have a completely free AWS Certified Solution Architect Professional Exam Guide. And it'll start you from the very beginning, and it'll get you all the way to cloud hired, or at least partially the way there, at least the technical components of cloud hired. So download it. It's completely free. My team and I wrote it, and we're happy to offer it to you. So today we're going to get back into talking about networking, which, let's be fair, is one of my absolute favorite topics in the world. And yesterday we started to do some, and today we're going to do a lot more. Ruben, good day. Gaurav, good day. Good to see you. Chijoki, good to see you. We're happy to see you. Earl, CCNA, fantastic. Darstarda, welcome. Hello, CCNA. Eva Doikia, good to see you. Thank you for having that blue wrench again. LM, it's nice to see you, LM. Precious, thank you so much. And yes, the blue wrenches. Eric, welcome back. Hello. LM in Mozambique. If you're the family I know, it's wonderful to see you. And if you're not and you're from Mozambique, it's wonderful too. Theo Q. Sharon, wonderful. Good to see you this morning. Nick B, hello. And yes, thank you for those blue wrenches. Anasaya, yes, CCNA. Fantastic. So let's do this. Alexandro, CCNA, Kalispera. Mick B, CCNA. Let's do this. All of you, if you're ready to get started, type hashtag CCNA. And then I'll know you're here. I see some people are already doing it. BD DuPoint, Nike, always wonderful to see you. Marjan, good to see you. Sharon, CCNA, fantastic. Cloud hired, network hired. That's my motto. Sanchin, CCNA, Linux, CCNA, fantastic. Cloud hired, yes. CCNA and cloud hired. Ruth, go cloud. Thank you so much. Hello from Gambia. Welcome from Gambia. Hasnat, good to see you. CCNA and Precious, CCNA and Brian, CCNA and Sarah, CCNA and Faisal, cloud hired. I'm all about that. Caroline, good to see you. Angelo, good to see you. Caroline, CCNA, yes. Rhea, CCNA and cloud hired. And Emmanuel, CCNA. And Millicent with the smiley face. Good to see you, Millicent. Stella, Chijoki, and Earl, CCNA. So, Georgetta, CCNA, and Sanchin. So, Stella as well. Okay, good. Theo Q, CCNA, and Precious, CCNA. All right, Amandu, I love it, CCNA, and Faisal. Cloud hired and CCNA, and Ryan Wagner, CCNA. Fathy, CCNA. Jeannie, CCNA. Jeannie, I'm so happy you're here today. So fantastic. And Mick B, CCNA. Danica, CCNA. And wow, Ruth, CCNA as well. Faisal Cloud hired. So Williams, I'm loving this. Always wonderful to be here, and we are excited to be here with you today. MJ, CCNA, I love this. And Jeannie, it's good to see you. Jeannie, we're going to get involved in some fun routing stuff today. And thank you. We were very happy to help out, Jeannie. So today we're going to talk about routing. And yes, hit the like button. If you're not a subscriber, subscribe. If you know others that want to learn networking or cloud computing, please invite us to the channel. Share it. You know, we want to help as many people as we can. And that's why we do so much free content, is we just know that it's not easy for everybody. I'm going to make sure my cell phone's muted because let's just face it, I get a few thousand phone calls per day. We don't want anybody getting in the way of our networking parties. So we're going to talk today about different kinds of routes. And I know I already got us a little bit past some of these things, but that's okay. We're going to talk about it. So I really want you to get the concept of routing. And really the concept of routing is going to be as follows. What we actually do is we take data and we go to the device that has the next level of intelligence. So over here, we've got a PC, and a PC doesn't have a routing table. At least most don't. I mean, sure, you can stick 8 network interface cards in a server and you can route between subnets in it, sure. But, you know, most PCs have one Ethernet card and you plug it into your switch, which goes to your router, and everybody's happy. So I know we briefly talked about this, but I'm going to do it again and again and again in case you guys just joined, or if you didn't completely understand it the first time, I'm going to make sure by the time we're done, you do. So PC says, I want to go to www.gocloudcareers.com. So the PC does a DNS lookup and says, who has the IP address for www.gocloudcareers.com? And then the PC knows it's the IP address. So the PC looks at its routing table and says, do I have a route? And the PC doesn't, because the PC is not running OSPF, BGP, or routing protocol. But when we install most of our PCs, they have something called a default gateway. The default gateway is where you go when you don't know where to go. So if router 1 is the default gateway, the PC says, I want to go to www.gocloudcareers.com. And then DNS tells them what is the address site. And then what does this PC do? It says, I need to send my device over here. Arp, who has the MAC address? And this router responds. It's called proxy ARP. I have the MAC address. So the PC sends this device here. Now, when the traffic gets to here, the router looks in its routing table and says, what's my next hop? To the B. So the router sends it to a next hop, and then the router says, what's my next hop? And it sends it to the next router until it gets to the server. Now the message gets to the server, and the server is doing its thing, and it says, I'd like to respond to the message. I am www.gocloudcareers.com. So the PC looks in its routing table. Does it have a routing table? It's got one route. Maybe it's got a route to its loopback, and it's got a default gateway. So the PC says, I know what to do. I'm going to send it to this router here. Who sends it to this router here? Who sends it to this router here? Now, once it gets to this router, the router looks on its subnet and it says, I have the route. ARP, who has the MAC address? Well, I actually knew it from the previous one, from the previous request, and it sends it through the switch. And that's how routing is going to work. So I want you to look at the routing logic. Routers have what's called a routing table. And that's basically a map of how do I go here? How do I go there? How do I go to Eva Deutke's house? Get into the car, drive to the West Palm Beach airport, fly to London, fly to Hungary, pick up a car, make a left, make a right, make a left, make a right. That's how we do it. So routers have a routing table. It's kind of like the GPS in your car that tells you rerouting, recalculating, here, there, go. So the data comes in and the data gets sent. It's really that simple. So look at it this way. Router wants to reach this device over here. This is Cindy the cat on my computer tearing things apart. Over here, we got Eva Deutke over there. So Cindy the cat wants to send a message to Eva Deutke. So Cindy the cat gets on my computer, and with her little paws, she walks on the thing, and it's poorly typed, but she sends it to Eva Deutke. She managed to get her IP address right. So she sends a message to 172.16.2.9. So again, I'm going to walk you through one more time. PC says, do I have a route? The PC does not, but it has a default gateway. So it sends the message here, which then looks in its routing table and says west and up, which goes here. And then this says it is directly connected. So that's how it works. That's how it works. So let me show you this. What happens is the routers and the PCs build something called an Arp Cache. And what really is it? It's after the PC now knows that the router has the MAC address for reaching Ivadoikia, it puts it in its table. And why does it cache it and put it in its table? So it doesn't have to go, Arp, who has the MAC address for Ivadoikia? And it does this for the following reason. If these devices send broadcast, we'd be full. The network would be full. So we cache this. Why do we cache the DNS requests on our PCs too? And we'll talk later about what is domain name system and how does that work? Because otherwise they'd have to ask the same question every single time, so they cache it. So keep that in the back of your mind. That's what's going on. See what happens if we've got our IP packet, like we talked about, and because we're putting on an Ethernet, we have to put an Ethernet header, which is how it goes from a packet to a frame, from layer 3 to layer 2. So what your route table is going to look like this. Let's say we've got a packet that comes in on gigabit Ethernet 00. We've got our packet. And then the router looks at its routing table and says, I know this subnet, this /24. Send this subnet out to reach this address. Send it out serial 0/0. Hey, guess what? To reach 172.16, use this interface. To reach 172.16.4, you don't have a route, so the traffic's going to be dropped. How about reaching this one? There's no route, so guess what? It's going to be dropped in many cases. If there's no path, that's what happens. So we're going to actually start getting involved in a lot of routing configurations. So we're going to make sure we have our fun with this and just make sure. So we don't need to, let's go here, let's go here. So let's deal with some different routes, and we're going to have some fun with it. So let's go back to our happy EVENG server. And let's just, what we'll do is we'll create a new lab here, and then one second, close lab. Let's go create a lab together. If any of you guys ever desire to get an EVENG server, these things are great. If you're in a hobbyist perspective, there's a GNU3, which sort of works out okay as well. There's also a Cisco, I think it's Packet Tracer, that's another good product. Or you can just buy a cheap CCNA rack on eBay. I highly recommend that. So now that we're going to do this, we'll get 2 routers. Actually, let's do this. Let's give ourselves 2 routers. And we'll be doing some stuff with some switches too, which is going to be really fun. But let's just connect these 2 routers. Actually, while we're at it, let's add a 3rd router so we can have a little bit of fun. Let's have a little bit of fun with this. Let's start them all. Okay, so what we're going to do is we're going to start configuring some IP addresses on each router, and then we're going to configure some static routes. Then we're going to walk into some dynamic routes. We're going to have all kinds of fun when we go through this. But remember, we need a path to get to the destination. So what we're going to have over here is going to be as follows. Let's make this guy router 1. And it's booting. These things aren't the fastest things in the world, but they do their job. After we do this, we're going to look at ARP tables and things. So I just want you guys to get a real feel for everything.
All right, so it looks like we lost Mike. The powers went out at his house. He'll be back on in just a second. So I will entertain again. I think I've got pictures of some new cats. Let's see if I can find them. If you could let me know if you can hear me in the chat box, that would be great. All right. Abigail, I need you to send me a picture of your cat. All right, let's see. So while we wait for Mike to come in, we will find some pictures to share because we love our cats. All right. All right, so here is a picture of Cindy the cat. And Cindy is probably the reason why there is no power. She's probably knocked something out, chewed a wire, pushed a button. Who knows what she's done? But she is our resident intern at Go Cloud Architects and Go Cloud Careers. And let's see, I've got a picture of some of our other Go Cloud animals. Let's see. All right. And there is a picture of Sunny the cat. Let's see. I think we've also got some dogs in here. Oh, here's Abigail's cat. Such a cute cat. And I don't know if I'm pronouncing the name correctly. I think it's Nani or Noni. I'm not sure. And I believe it's a he. But if you can't tell here, I think this is a hamburger and French fry bow tie. So apparently Abigail's cat is after my own heart. I love French fries and hamburgers. Oh, just a second to grab my phone. All right. Now, we're not all about the cats here. So here is Marla's dog, Rocky. And let's see. I'm not sure what kind of dog Rocky is, but he is definitely a cutie. I think he's wearing a sweater here. I could never put anything on Sunny. Sunny, we tried to dress Sunny up as a hot dog one time, and that did not go over very well. Let's see. Oh, no more pictures. I was hoping we had more cat pictures. Darn. Well, while we're waiting for Mike to come back in, if you've got any cat pictures or dog pictures or pet pictures, make sure you share them with us, either on LinkedIn or by email at admin@gocloudcareers.net. All right, there we go. I was torturing them with cat and dog pictures.
Thank you so much. So everybody, what happened is I live in South Florida. We had a very short power outage, and apparently the UPS on my firewall / router that's home to 2 different internet service providers, the battery didn't work on my firewall. So I had a power outage, but we're back up, so we should get involved in some fun. I didn't build my house into a 5 nines data center with multiple generators like you would in a real data center. So this is just part of the fun. So let me get back to the content over here. While we're doing this, let me see if I can hope that my EVE-NG server didn't reboot with a different IP address, which it probably did. So we'll have to figure that new address, but we'll get there in a minute or two. So everyone, while we're here, while I'm trying to find out the new IP address, yes, Cindy does do a lot of funny little things. Does real cute stuff like that.
Yes, she does.
All the time, every single day. So, addressing in VLANs, we're going to figure out where our server is. Bear with it. Yeah, Noni's a very beautiful cat too, actually.
Yeah. Yeah, I need to make these pet pictures more readily accessible.
Yeah, you mean every time I
love Angela's comment here. One is none. I need another cat.
I've actually been thinking about getting a second cat for the following reason. Every once in a while, what ultimately happens is the cat goes out for a little while, and then she's not here to play with me. So yes, I'm thinking this. Okay, so we're almost figured out what the IP address of the server now is now. So now we've got to go look at my firewall and try and figure out which .128 is actually a what's the word I'm looking for? Is actually in the subnet. So it can't be this. Can't be this.
As Fathy says, even AWS had a power outage, but we had cat pictures during the outage. So
that's true. And I don't build my house like a 5 nines data center. For that reason. Okay, maybe it's not 155, not 160. It's still here as .150. So let's see why that's not working. So let's see. I'm still showing it. Let's see if I can do it. 192. No. That is not working. So let me power cycle that server, and then we'll be up and running.
This is where we really need to look into licensing some music.
You don't like me singing Jeopardy music?
I I have an affinity for the original, no matter what it is. The original is always better.
I was going to ask you to find some last night so we could do better. But everyone, we're going to be here. We're just rebooting our EVE-NG server. Let me tell you. In a data center, you have 2 power companies, you have 2 generators, you have backup generators, you have batteries. And my wife is determined that there's a wee bit too much technology in my house making noises.
Let's see where everybody's from while we're waiting.
Yeah, ask everybody while we're trying to wait for our server to come back up.
So I know we've got people from all over the place. So in the chat box, let us know where you're from, and let's see how far we stretch. Maybe we've got somebody in Antarctica now. I don't know.
Winnipeg, Canada. That's pretty cool.
I've had Jazz on top of trying to do our Antarctica recruitment, but not many prospects down there.
Yeah, we haven't been finding a lot of people in Antarctica. I don't know why.
We got somebody from Mars, I see.
Nigeria is fantastic. That's semi far away. We've actually got a lot of wonderful students there. Maryland, Frankfurt. Yep. That's kind of exciting.
Oh, all right. Toronto.
Okay. So we've got some stuff coming up, and my
South Boston. If only we could hear that accent from South Boston.
Yeah, that's definitely one you can always pick up.
Yeah, even me, a guy who grew up in Mississippi, I can pick out a South Boston accent. And I'm assuming this is Paris, France, because there's a lot of Parises out there.
Yeah, like Texas, Paris, Texas, Paris Island, Virginia. Boy, is that a hot place in the summertime.
Denmark with Evdokia.
Okay, sir, you can't be taking that long to come up. Seriously, I'm looking at you on my firewall.
All right. Zimbabwe, Haiti. Of course, we have Leo in Brazil. UK. Mozambique. Got quite a few people from Dallas I've started to notice lately. The Metroplex area.
Kind of a big tech company.
Mm-hmm.
Big tech area. Okay, destination host unreachable. Oh, why is this server not up even though it says it's up? Cindy, did you unplug a cable again? No, it couldn't have been because she's not in my room.
She's sneaky. Portugal. Ghana.
Let's see, maybe. Oh, not yet. I still can't ping it.
Ivory Coast. All right. If you hadn't already done so, make sure to put where you're located at in the chat box. We always like to know where everyone's watching from, learning from. Our GoCloud family is a very diverse and widespread family, so
sure is.
Make sure to share that with us.
Well, I'm not sure if we're going to be bringing the server up today, or if I'm going to have to rebuild the entire server from scratch or trying to figure out where it's at. But if that's the case, don't worry. We could still talk networking and have lots and lots of fun with it. Because it looks like our server's up IP address wise, but not answering anything according to a ping. So that's never a good sign. I wonder if I can clear the MAC address table on this. No, that's going to come. All right, well, let's talk about some networking without some routers for a little bit. See if we can figure out what's going on after the fact. So that's okay. We've got lots of ways we can play with this. So let's talk about, when we're looking at routers, what are we going to be looking at? What is the special sauce that we're looking at? So what we're really going to be looking at is we're going to be looking at the configurations, and I'll show you what these mean. And then basically speaking, we're going to be looking at the routing tables. So let's go back in this particular environment. Let's see what we have here. So, if we're looking at the running config, so our routers are going to have two configurations. They're going to have the running config, which is up what they're running with, and they're going to have a startup config, which is what they boot with. Now, if you do everything right, you configure your device, and you either do a copy run start or copy running -config to startup config, or you type WR or write memory. What it's doing is taking anything that's going on in the system, and it saves it so the next time your system's booted. Kind of like this. If you save your document in Word, it's saved for you. But if you don't save your document in Word, guess what? It's not. And not being saved, it's not going to be there the next time. So kind of keep that in the back of your mind. We're looking at the running config. Now, as we network engineers and architects, we're really concerned about whether our traffic gets to its destination. So half of what we're going to look at is we're going to be looking at our show IP route. Now, when we do this, we're going to see the full look of the routing table. And the routing table will tell us how we learned these routes. Did we learn them from OSPF? And if so, guess what? They're going to say, oh, are they in between areas in OSPF? And if that's the case, guess what they're going to say? OIA. If they are external, and we'll talk about that later, they're going to say OE2. But the point is, we're always going to know from what the routing table looks like how we learned it. So let's walk through this scenario here. This route over here, this specific 172.16, that's the CIDR range, right? Now we can see that 172.16.1.0/24 is all directly connected to Gigabit Ethernet 0. We also know that we can reach 172.16.1.1/32. That's the directly connected. That's the IP address directly on this interface. Then we can look over here, the 172.16.4.0. We can see that's again directly connected, and we can see the IP address on that interface. Same thing for this subnet. So that gives us a lot of things. Now, I mentioned what happens is when we go from a layer 3 address to a layer 2 address, what we're really dealing with is we're looking at the MAC address. We're going to keep a table of MAC addresses. Now, I previously had told you that the way we do MAC address tables is really as follows. The way we're doing the MAC address table is we're going to store it in the routers, and it's going to be in the form of an Arp cache. So we're going to be storing it in the Arp cache. So let's look at what the Arp cache shows us here. If I do a show IP ARP on the router, it's going to show us the IP addresses and the MAC address and how long it's been there. So look at this address, 172.16.1.1. This is the MAC address that's associated with that. And we know that we learned it via Gigabit Ethernet 0/0. So that gives us a bit of an idea what's going on. Now, the next thing that we have is we've got another IP address that we learned. And we can see we learned that 35 minutes ago, but what else can we see over here? We can see a lot of really cool stuff. We can see the IP addresses, et cetera, et cetera, et cetera. So, we kind of know a lot of what's going on here. So I know we did this yesterday, and I was going to do some more with you, but, technology does what it does. Bill Gates was demoing Windows 98 and his computer crashed. I live in South Florida. We got a power thing every single day of the week. Usually my surge protectors, UPSs do their job, but occasionally we figure stuff out. So let's look in this particular position. The PC is here. He wants to reach the far end of the link. So what happens? The PC is going to the PC doesn't know where to go. So the PC has a default route. Now, what if on this router, we did a route that said IP route 172.16.2.0, send it over here. That would be a static route. It would work perfectly. I do this, 172.16.4, go to this next hop. Now, once it's on this router, that router is going to say, you, everybody, ARP, who has the MAC address, and this guy's going to respond. So this guy responds to the router, assuming this router has a static route that says to go to 172.16.1.0, go here, or a default route that says if I don't know where to go, go here. Anytime we have that, Now we're in a position where we can really do some pretty cool stuff, because that's how we have the ability to go from point A to point B. How do we learn it? What do we know? Why do we know these things? We know it, quite frankly, for the following reasons. And they're very simple reasons. The routes are there. We're looking at the routing table. So those are the kind of things that we're trying to look at. Kind of keep that in the back of your mind. Keep that in the back of your mind, and you should be in good shape. Okay, so now let's look at another environment, like where we would put a static route. So if we put a static route in here, you know what we'd have to do is we'd have to tell this router, hey, by the way, to reach this subnet, go here. So what I do, I'd be on this router and I would type up a command that looks like this: IP route 172.16.2.0. Next hop, we would find this IP address, and it would be, let's look at it, 172.16.4.2. And that would be my next hop, because that's what we see over here. So, you know, keep that in the back of your mind. I'm trying to see if I can try and bring up my server a little bit. Trying to bring it up there for you. Doesn't always work, but I'm still trying to see if we get lucky and can bring it back. So now if we do a show IP route, we'll get it. But if we do a show IP route OSPF, a show IP route static, a show IP route BGP, you'll see what we're going to get here. We're going to be able to filter it so we don't have to look at as much. So if we do a show IP route static, note what it looks like. You see an S next to it. If it was learned via RIP, which we don't use, guess what? It would say an R. So kind of keep that. So we can create a static route for a host, or we can static a static route for a subnet. So this is a host. We route this to a single next hop IP address. Now this is a regular static route. This is a route for 10.1.1.0/24. So it's going to take anything that looks like this and send it over here. Now here we're going to have a route for a specific host. And why is it specific? We're going to go 10.1.1.9, 255.255.255.255. Guess what? That is an exact match. 10.9.9.9 is the next hop IP address. So you can keep that. Now there's this concept of a floating static route, where you can have a static route, and if it goes away, you know, it goes away. But reality is why are we doing floating static routes? All we can realistically do, and the best place to do this is we can make it quite simple. We can just use a dynamic routing protocol. But what we could do to make this more believable is we could say, hey, wait, this is preferred. If this doesn't work, we could have a manual static route. So what is this going on? We're running OSPF over here, and we're creating a static route over here. So how is this going to work? If we actually look at the route, if we do a show IP route over here, what we're going to see is the static route has this weird thing over here where it says distance of 130. So what is distance? So the Cisco routers have the ability to determine which route is more believable. So on the Cisco routers, they have things with regards to believability. So which do you think is more believable? A route that I physically said, hey, go here, versus someone that somebody heard from somebody else. The manual static route that I pop there is really believable. So what happens is the Cisco routers use a concept of administrative distance. And they look at routes and routing protocols. They look at RIP, which is a terribly unreliable protocol, and they give it a high number. They then look at things like IGRP, which is not the most believable protocol in the world, and they give it a relatively moderate to high number. They look at external BGP and say that's pretty accurate. They give it a metric or administrative distance of 20. They look at an OSPF external route and they say that's less believable than a standard route, and it's got a different distance, et cetera, et cetera. So EIGRP will have its distance. External routes via EIGRP will also have different distances. And what we have to do is, if we want to override the default behavior of a routing protocol, we have to say, hey, more believable or less believable. And we do that by playing with the distance. There's a distance command on our router. So if I've got 2 routes to Chris's house, I learned one route via EBGP, which has got an administrative distance of 20. I put a static route to Chris's house that's got an administrative distance of, say, 1 or 0. And that's more believable. But if I took that static route and changed the administrative distance to, say, 130, and I learned the route to Chris's house via EBGP, which is, say, 20, the route to Chris's house would be far more believable than the static route. Now, if I change the distance to that static route back to 1, poof, all traffic will be taking the static route versus BGP. So that's what we're talking about when we talk about administrative distance. We have the ability to make certain routes more believable than others. So we could use a static route at really low speed links to not send them. So let's look about adding a static route. How do we do it? Well, in this case, we're going to create a default route. So what do I do with routers? We do config T or configure terminal. But, kind of keep that in the back of your mind, config T. Then that'll enable us to do it. So here's the routing command, IP route. In this case, it's a default route, which is 0.0.0.0, exact match 0.0.0.0. Send it out serial 0/0/1. That'll work. Now going back, this will show you how we learned it. So if we look at the routing table, note it says S. Why? Because it's a static route. Note this says C because it's directly connected, and L means link local. So keep that in the back of your mind when you're there. So let's do another set of routing. Permanently adding static routes to the routing table. We can basically do the IP route. Look, this is a route where we're sending 172.16.2.0 out serial 0/0. And I'm going to tell you this, I don't ever like to make static routes this way. I like to do things intelligently, which is where I like to give them an actual next hop. So I would prefer to do this 172.16.2.0 and then give an IP address of the far end as opposed to which interface to just leave and hope somebody else takes it over. And here's where you can see an example of using an exact match IP route. We're going to take the 172.16.3 subnet /24, and we're going to send it here. That is a very explicit route. So now in this particular case, let's look at what we're getting. If we do a show IP route OSPF, we might find that we've got a default route that we learned via OSPF. Note that distance is 110. And what you see next to it is the metric or the cost to get there. So you can see this is what's going on. We do a show IP route. We can see what the next hop IP address is, and we can see the outgoing interface. So what do routers do? I got 2 limbs. I look at this. I got a packet on one limb. Packet comes in. I look in the routing table. I say, go out that limb. And then I'm like, nope, nope, nope. Go out this limb. Nope. Go out that limb. Go out that limb. So routers are like octopuses with limbs everywhere. They take the traffic in and they send it out as fast as they can out another limb. That's what routers do. So just kind of keep that in the back of your mind as we're doing some of these things. So let's kind of look at some of these things that we can potentially do, and some of the administrative distances and some of this stuff. So there's that concept. Now we had less visuals and less labs to be able to demonstrate this. So let me do this. Let me see if anybody has any questions for about 15 minutes, and then we're going to get to routing. And we're going to talk about router on a stick and switched virtual interfaces and switched ports, etc., etc., etc. So Chris, if you want to look through the chat box and see if there's any questions.
Yeah, there's some questions related to career and training preparation for cloud careers. But if you'd like to answer that, we can, or if you want to suggest that they come to our session on Monday, we can do that.
If it's on a couple, let's answer a couple questions and go back to the content, and then we'll invite anybody to the session Monday. So, okay, so Sham Malik, let me be very clear. There are no certifications that will make anybody a cloud architect. Absolutely zero. What makes people a cloud architect is as following: extreme knowledge of the network and the data center, and knowledge of the way the cloud works, how it works, and how to design systems on the cloud. It takes knowledge of virtualization, knowledge of firewalls, knowledge of VPN concentrators, knowledge of servers, server virtualization, containers. It takes knowledge of system design. It takes executive presentation skills, executive communication skills, CXO relevancy, the ability to do an ROI model, the ability to give a presentation in front of 1,000 people, the ability to sell $1 billion solution, the ability to show the customer that if they buy $1 billion of technology, that really they're going to get $3 to $5 billion in business value by generating a business case. It involves, asking a customer about their business challenges and creating a design. And none of that is covered in certification training. To train that, you have to master the network and master the data center and master the cloud and master system design, communication skills, et cetera, et cetera. Now, we have a program for that, and you can do it, but you can have the AWS Certified Solution Architect Professional, the CCIE, the Google Professional Cloud Architect, and still not be hireable as an architect unless you get those skills. So it's not about certifications. Certifications don't get anyone hired. Now, certifications build your resume, which can get you an interview, which is why we do certifications, to help get that interview. What gets you hired is in the knowledge in your mind, the right attitude, energy, enthusiasm, communication skills. We've got a program for it, but that's what you need to do. And join us on a Monday or Wednesday, and we can go into extreme depth on how to do this. Chris, do you want to bring in the next question? But every one of you can get these jobs if you put in their fight. Angela, use cases of using spanning tree versus routing. Well, Angelo, as a rule, I haven't used spanning tree in 20 years. Why? Ever crazy spanning tree network, I ripped it out and I put layer 3 routing, and the comp thermal was really helpful. So if you've got 1,000,001 VLANs for some reason, and your team doesn't enjoy routing and they don't have the sophistication for routing, people do switch networks. But if you've got the sophistication for routing, don't do any of this layer 2 stuff. You're going to get yourselves in trouble with spanning tree loops, bridging loops. It's fairly complicated. And it's easy when you compare how spanning tree works to OSPF, for example. But chances are I don't use a lot of spanning tree, and I use routing because routing is fast. And it's easier to avoid a routing loop with good configuration than a switching loop. So it's a good question, Angelo. If you've got the ability and you have good routers, you're going to use routing. If you don't have the ability and you're looking for just simplicity, you're going to switching. But that's a good question. LM, what is the advantage of using the default router? You have to have a router. So if you don't have a default route in your PC, you're going to have to manually add a route for everything. A route to one website, a route to the next website, a route to the next website, a route to the next website. Or your PC would have to run a routing protocol with your router, such as OSPF, EIGRP, BGP, et cetera, et cetera. So you have to have a destination to get there. So if you don't have a default route, you have to have the exact route. So on internet routers, guess what? They have full routes, no default routes, full routing tables. But unless you want to take on a full routing table, LN, which right now is about 800,000 routes, and stick all those 800,000 routes in your PC, you're going to have to use a default route on the PC. And that's why, because it says if you don't know where to go, go here. Otherwise, you need to take in the 800,000 routes. Excellent question. Tech with me, fan. Okay, this is an extremely good question, Tech with me, fan. So if we run a routing protocol like OSPF, it's automatic. If we don't run OSPF, we have to configure static routes. And by creating static routes, that's going to build the routing table manually. So it determines whether you use static routes or dynamic routing. That's really the part that helps us configure this. Good question. Use cases for bridged internet and enterprise solution? Ugh. I can't think of any use cases for which I would do it without ripping it out with a layer 3 link, but people use bridging for the following reasons. Like if you're going to connect to AWS, they want you to send them on a VLAN, and they're doing this because They assume it's going to be too complex to have a layer 3 link going back, and they're trying to avoid it. So they're using layer 2 bridging. You know, if you wanted to extend VLANs across a campus, you'd be using bridging. Or you could just create extra subnets on your switches and route between them and have good access control lists and filters and QoS policies between them and not have any of these problems be routing. So people like switching. So if you're dealing with people that want to run a layer 2 shop, you're going to use bridging. If you're dealing with routing people like me that really hate layer 2, you're never going to use any bridging. So I see of no point to use bridging when you can use routing, because the speed to heal is so much faster. But you know, keep that in the back of your mind. There are organizations that don't want to use routing protocols because there are people that don't understand routing protocols. Someone with good knowledge of routing protocols is a $200,000 employee. Someone with knowledge of spanning tree is a $80,000 employee. So lots of times people go for the spanning tree because they don't want to have to hire the sophisticated people to truly understand routing. Which devices use static IP and dynamic? Generally speaking, as a rule, anything that matters gets a static IP address. So your routers get a static IP address. Your servers get a static IP address. Could you imagine Asea trying to connect to a server, and today the server's IP address is 192.168.1.150, and then you get a wide system reboot, and then you get a 192.168.1.139, and you can't even find it? That's the kind of stuff that actually happens in these environments, and that's why we're really so critical of making sure that we never use dynamic addresses on servers. So PCs like your PC, yeah, that can get in a dynamic IP address anytime it wants. Not a big problem ever. Never. But by comparison, it is a massive problem if you need, by comparison, a server and its address changes, and you can't imagine going to a website that wasn't there because its IP address changed. What an excellent question you had there. Earl Owens, well, routing on a stick is layer 3 routing. Now, if you're asking whether it's better to route on a layer 3 switch than routing on a stick, we're going to get into routing on a stick and show you why it's probably the worst idea ever. Having said that, no, routing a router on a stick is layer 3 routing. And we'll show you what that means when we get to that content very soon today. Williams, as we configure the static IP address, the next hop is not a default router. The next hop is the next router on the link. So that's a pretty good question. So let's go back to this particular environment, because we wouldn't be configuring a static route over here. So let's go back over here in this particular diagram. So let's say I wanted this PC is going to have a default route, which says, if I don't know where to go to router 1. Now, router 1 could have a route that says, if I don't know where to go to router 2. That we could do. But we could just say, hey, to reach subnet 172.16.2.0, go to this next hop IP address. And that's typically what we're doing, because what if we had an internet connection over here? That would be where the default route would go. If this was, say, going to the internet would go here, we'd get a default route, and we'd have a specific route taking us to this next hop. So we can only do one default route. And the default route has to go for stuff that we don't know. The default route is almost exclusively pointing to the internet, because your routers will have a routing table of every route in your enterprise. So the only time you're ever not going to have a route, for the most part, is if you've done some route filtering to keep the routing table small, which is a very smart thing to do. Or you're going to the internet, and that's why you don't know where to go. So I hope I answered that question for you, because that was really a pretty solid question. Of course, we'll cover radius and 802.1x, etc., because it's definitely part of this content. Can I explain the concept of virtual routing and forwarding? Sure. So very simply, so here, let's create a new slide, insert, hold on, how do we do Oh, I see what's going on. Oh, that was not supposed to happen. So let's go back and let me find this. Apparently, I enabled editing to add a new slide. And as soon as I did that, that effectively kicked me out of being able to look at this. So let's keep going. Bear with me a second. Well, what we'll do is we'll just answer it up front, and then after this, we'll go back. So here's a switch. Got a switch. Take this switch, and and beside the switch, we group 20 ports together over here.
You're not sharing your screen, Mike.
So we create a switch here. These are ports 1 through 10. 1 to 10. That's VLAN A, which is ports 1 to 10. This is VLAN B, which is ports 1 to 10. Now this is going to be VLAN C, which is going to be ports. This is going to be ports 11 to 20. And this is going to be 21. Whatever, we just pick some ports to 30. And then I want to make this clear exactly how simple this is, even though it feels kind of complicated. And this is now the switch, which is got VLAN B, which is ports 31 to 40. Okay, so this is a virtualized switch. Now, VLAN A can't talk to VLAN A, VLAN B can't talk to VLAN B, VLAN C can't talk to VLAN C, and VLAN D can't talk to VLAN D. We just upgraded our switch to a router. Okay, now A is a virtual routing and forwarding interface, and this is for customer. So this is for customer 1. Now this is the virtual forwarding and forwarding interface for virtual customer 2. Now this is virtual customer 3 for the service provider. Now we've got the 4th customer. This is VRFC. And this is VRFD. And now this is customer 4. By the way, this VRF thing that we're talking about, that you're asking about, this virtual route forwarding, was what was created for one of the primary clouds, specifically RFC 2547 BGP VPNs. This is a cloud. This cloud was pretty much, it was done by Cisco and Juniper. Ivan Pepanajak wrote a really good book about it. I mean, it was really fantastic. He's one of the original CCIs. So instead of being a switch, this is now a router. So this is now AT&T's router. And AT&T now has your routing table in one version of OSPF, somebody else's customer in OSPF, somebody else's customer in OSPF, and somebody else's customer in OSPF. So we took a router and we just created virtual routers inside of it. Now, VMware 20 years ago, take a server, install a hypervisor, chop that server into multiple virtual machines. Okay. Cisco created the VLANs 30 years ago. Take a switch and chop ports up. 30 years ago, 25 years ago, we're starting to get into cloud computing. So what did we teach all the cloud providers? To create virtual routers where their customers' information is separate. So the modern cloud computing that we're using today with virtual routing and forwarding tables, where do you think this came from? Cisco 20-some years ago. So that's what we meant by virtual routers. And the cloud provider, everybody's got their virtual private cloud, which is basically their little virtual private data center sitting in the cloud provider. Guess what we're dealing with here? The same thing via Cisco 25 years ago, except when Cisco created this, they don't have to call it elastic. They don't have to issue 15 million press releases and pretend that it's new. It's something they did 20 years ago. It works great. Every service provider uses it. So I hope I answered your question. That was a really, really, really great question. Mark, pretty much the only routing protocols that we would ever use in today's world are OSPF and intermediate systems to intermediate systems. There are only interior gateway protocols that we'll be using. Exterior gateway protocols include BGP. And that's pretty much it. Now, granted, there's an EIGRP, which we don't use for the most part. There's a RIP v2, which we don't really use anymore, which are also interior gateway protocols. There used to be this thing called IGRP, which was this classful, ugly routing protocol that was a little better than RIP, but not as good as EIGRP that Cisco invented many years ago, about 3 decades ago. And then when they invented it, it was a good routing protocol. But in today's world, it's all OSPF. Where do proxies come in? Nowhere close to this. And it really has nothing to do with networking proxies. In fact, proxy servers are all systems admin work. And here's what a proxy is. And unless you're working in the Middle East, chances are you won't be using many proxy servers. If you're working in the Middle East, you will be, because direct internet access is not allowed in a lot of Middle East locations. For example, when I was in Dubai, every piece of traffic goes through a proxy server because they don't want to allow people to get to anything that's been deemed illicit. So, they use a proxy server. But here's what a proxy is. So you've got your network, got your computer here, got a user.
Make sure you share your screen.
The user wants to connect to the internet. So he connects to this proxy server. The proxy server goes out there and connects to the internet. And yes, we've always used a cloud for the internet. All a cloud means is you don't know what it is because the information is hidden from you. So now, user wants to go see www.gocloudcareers.com. This user is not allowed to go to the internet. It goes to the proxy server. And the proxy server says, can I go to www.gocloudcareers.com? And the proxy checks its list and says, allowed. So the proxy server goes to the internet. Internet comes back, and the proxy server delivers it to the user. Now, another user wants to go to the same website, www.gocloudcareers.net. And they hit this website, and it's already there, so it gets sent to them. So it just does some caching as well. Now what happens is this user wants to go to this AWS exam dump cheat exam copy of it. And the user sends its request. It hits the proxy server. The proxy server says, bad site, bad site, bad site, and sends a response back to the user that says, sorry, not allowed. So a proxy user is used to control the user access. And that's what a proxy server is. And again, it has nothing to do with networking and everything to do with servers and systems administration, but kind of keep that in the back of your mind. So are we going to talk about Cisco Wireless? Not a lot. We will a little bit probably, but not a lot. Why? Because we deal with predominantly architects, and cloud architects are dealing with people that need reliable, and we never put anything important on wireless. The only thing that we use wireless for is like desktop users roaming around, stuff that we don't care about. Everything that matters is all going to be wired, not on a shared multi-access network, just due to the kind of problems that we can occur. Chris, did we have any more before we go back to content?
Yep, we got one more.
Okay, let's answer one more. So the reason we use the BGP routing protocol for internet is as follows. BGP is extremely scalable, meaning we're going to take in 800,000 routes from internet service provider, where OSPF or other routing protocols will fall apart once we get to about 10,000. So we need the level of scalability provided by BGP. Additionally, in BGP, we do the following. We have the ability to take in routes from one person and another person and prioritize one link over another. So BGP is used because it's extremely secure, it's extremely scalable, and because it's highly tunable. So I can connect to this internet service provider, this internet service provider, and this internet service provider. And the things that this internet service provider has the best routes to, I'm going to go, versus this internet service provider versus this internet service provider. So we use BGP because of the scalability, the tunability we get, because no other routing protocol gives us that level of scalability. And that's a really, really great question too. Excellent, excellent, excellent. So fantastic. So let's go back to some content, unless there's any other questions, Chris, that came in since the last one. I will find out where we are in our presentation, since when I wanted to draw these to make some demos, it didn't cooperate very well. So be with you in a minute. While we're at it, if everybody can type hashtag CCNA. So now we're going to talk about routing between switching. So there's realistically a couple ways that we can do this. And when we're routing, when we're actually routing in between VLANs, we have two options. We have, the thing called a router on a stick. And mind you, I haven't used router on a stick for over 2 decades because it's the worst possible thing we could do, and I'm going to show you why. Or we could use switched versatile interfaces, or we could not do anything crazy like a router on a stick. We could just create a cable from each VLAN to the router, and that will be not as good as a switched versatile interfaces, but nothing out there is as bad as router on a stick. And I'll be demonstrating to you why. So please remember this. In this particular environment, if this switch has 2 VLANs, and this switch has 2 VLANs, and this switch has 2 VLANs, we are going to have to be able to route between VLANs because VLANs can't talk to each other. Now, there's 2 ways we could do this. We could have, if there's a VLAN, if there's 2 VLANs here, we could have 2 Ethernet ports on the router. One cable would go to one VLAN, and another cable would go to another VLAN. And we could have one cable to go to one VLAN, and another cable to go to another VLAN, and one cable to go to this VLAN, and one cable to go to this VLAN, and we could route between them on the router. That would be perfect. Everything would work fine. So one cable per VLAN goes to the routers. I got a gigabit for VLAN 1 and a gigabit for VLAN 2. How much throughput is that over 2 gigabit links? 2 gigabits. Now, I can do router on a stick. Router on a stick is create a trunk port between this one switch and this router and route between VLANs. So now we've got a 1 gig piece of fiber. We've got VLAN 1 and VLAN 2. So of that 1 gig, we're sharing it amongst 2 VLANs. Now, let's add 10 VLANs to the switch with this crazy router on a stick concept. We're now going to put, and I'm going to show you how to do it, all 10 VLANs all on a single port. So we're now going to have to share the bandwidth on it. So router on a stick was this horrible thing that we did back in 1990 something. But the performance of it is so bad. So what's it going to look like over here? I'm going to draw it out for you again. In this particular environment, we've got a router. We've created a trunk port, trunking VLANs 10 and VLANs 20. We're trunking them back to the router, and the router is going to have 2 sub interfaces, and I'll show you what that looks like. So on the router, what we're going to do is we're going to go to the interface itself. And what we're going to do is as follows. We're going to take the running config, and we're going to go interface gigabit Ethernet, note 00. Note that little 0.1. What we're doing is we're taking our interface over here. We turn the interface on, and then we create a sub interface. And in here, we basically call it interface gigabit Ethernet 0/0.1. And then what we do is we tell it to trunk VLAN 10 inside of this gigabit Ethernet part. We say gigabit Ethernet 0.0/1. Here, take VLAN 10. By the way, here's an IP address. And then over here, we say we create another sub interface. And we tell it trunk with a .1Q tag VLAN 20. And we give it a different address. Note what's on a different subnet, .10.20. So then when we configure this on the device, here's what it's going to look like. It's going to look like as follows. We've got the IP address over here. And in this particular case, we've got a sub interface with an encapsulation. So you can see what we've got it. We're going to look in our routing table, and here's what you're going to see. You're going to now see that you've got this subnet on this logical interface that we just made, 0.10. We can see what the IP address is in the local interface. We can then see we've got another, guess what? Another sub interface on this thing, which of course has its own subnet and IP address. So now when we look at this, what are we seeing? We're seeing the internet ports and all of the sub interfaces. So now let's go look in here. And as we look in here, let's look at the VLANs on the switch. We can see we've got these VLANs. We can see what's going on with these VLANs. And it really gives us, a fair amount of things. So the only problem that we're really talking about right now is this. And this is a pretty significant problem. We've got a router that may have 50 ports on it, or a switch that may have, let's say the switch has 100 ports. And they're all a couple of VLANs, and we now stick this on a router. And we have multiple VLANs all on a single cable. So let's say I'm drawing this. We've got a switch over here that's got 100 ports. I just drew a router. Now I'm going to run a cable between them. This router, if this is a trunk, all on a single port, is going to be maxing this gig out. This link is 1 gig. 1 gig. So picture this. Let's say on this link, we had VLAN 10. VLAN 10 needs 800 megabit per second. Now let's say VLAN 20 needs or desires or could use 1 gigabit per second. And this is nothing. 1 gigabit per second. I mean, I send more data than this in my house. Now, if this is the case and this link is only 1 gig, not so good, which is why I say router on a stick is about the worst idea in the world. Not so good. This link is the constraint. And can this router even do a giga throughput? That's another story. Where switches are designed for this. So now, if we had 2 VLANs and 2 cables, and each cable was 1 gig, do we have any constraint on the network now? Or is the network smooth and high performance without that little thing? So, do we all see why I'm talking about not loving router on a stick? Does it make sense to people when I say router on a stick is not necessarily the most beautiful, simple, and elegant solution for that reason and that reason alone? Is that obvious to everybody? Because if it's not, let me know. And if it is, let me know in the chat box. If you get this and understand why I don't like router on a stick, tell me CCNA, #CCNA/got it. Because I want to know you got it. And then we're going to get into the other ways to do this.
We're missing your Jeopardy music, Mike.
Oh, that's right. Do 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 do. Boom boop 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 boop. Bum 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 bum. Okay, tech with Mufaz, you don't get it. So, tech with Mufaz, I want you to think about this. You've got two cars that are each trying to drive 100 miles an hour down a link that only supports one car at 100 miles an hour. When we add the second one, both slow down. So, got a big pipe and a big pipe, life's good. You got 2 things that you want to shove down the same thing, everybody suffers. So router on a stick, if I've got 100 gigs of throughput that I need to do, and I've only got a 1 gig point, we got a problem. So Mufaz, heck with Mufaz. The thing is this link is the constraint, becomes a constraint. So we might need more than one link, and that's the reason why. That's the reason why. So hope that makes sense. Now let's talk about the other way to do this, the real way to do this. So with that router on a stick idea, it was terrible because we had everything going down a single trunk port. Now it would get better if we had multiple cables per VLAN. So that would be cool. But really, the only intelligent way to do this is with a layer 3 switch. So what is a layer 3 switch? What if I told you that you could put a switch and a router all in the same device? And it would look like this. Instead of doing this ridiculous router on a switch, what if I took my switch and inside of my switch, I could let's get rid of the fill. Now this is what to put it into context for you. This is what we've been doing now for about 20 years. Let's just make the text the right color. So now let's draw ourselves a VLAN. VLAN A. VLAN B. VLAN C. And then VLAN D. Let's have some fun with it. So let's say ports 0 through 9 are here. And let's say ports 10 to 19 are here. And let's say this VLAN uses ports 20 to 29 over here. And then let's say over here with VLAN D, we do 30 to 39. These are the ports. Now, right now, there's no way to route between them. None, because they're routers. So we have two options. We could do it smart. Well, if we had a router on the stick, which we don't want to do, we could do a router here. And what we could do is we could run a cable from here to here to here. And then we could run a cable from here to here. And then we could run another cable from here to back over here. And then I could run another cable. Well, by doing this, guess what? I've got 4 cables. So I have less of a bandwidth problem, which should be good. So, we don't want to do that. So what if we could actually create an interface inside of these devices called an interface? What is an interface? It's a subnet. It's a logical device that needs a subnet. And we could put an interface, and this one was 10.0.0.0 or .0/24. And this one, let me do that. And this one over here is 1.0. And this is 2.0. And this is 3.0. What if we could just pop an IP address on the VLAN and then turn on the routing function in the switch and ask the switch and take the switch. So here's what these typically look like. So you've got a switch over here. And actually, let's build out the switch for you guys so you can see what it looks like. We're going to turn this into a full switch. So the first thing we're going to do on this switch, because we're going to assume this is a high availability switch, we're basically going to put what's called the control module. And this is the brain for the switch. And then 1 is none, 2 is 1, and 3 is greater than 2. So if we care about this switch, we're going to put a backup control module in case the 1 fails. Now, let's think about how to not have problems in our network. Do we think that we're going to be in an environment where power failures are never going to occur or circuit breakers are not going to occur? Of course we know they're going to occur. And we plan for these things to occur because that's why organizations don't really have power failures. In fact, other than AWS, I haven't seen a power failure in a data center in 25 years because organizations have generators and backup generators, but so there's there. So we're going to have 2 power supplies. And these power supplies are going to be plugged into different outlets and different circuits. This is pretty normal. Going to different power sources. Now we can put a router module in here too. So now there's the router module. If we've got a router module, do you think one is enough? No. One is none, two is one, and three is greater than two. So let's put a backup router module. Okay, so now we've got a relatively high availability router. Now on this router module, inside the same switch, we can just route between these VLANs because the router module is in the switch. So all these cards, all these VLANs, they plug into the back of the switch. It's this fabric that's got ultra high connections from port to port. So directly in the switch, we're routing in between VLANs. This is the coolest thing ever. Coolest thing ever. I mean, when you start looking, well, I probably should have put that in there. The router is going to route between VLANs, and this is what we've been doing for the last 20 years or so. This is what a layer 3 switch is. This is exactly what a layer 3 switch is. We route in between them. So this is the alternative. So, you know, this would work, although this is 1980. I don't want to call it 1980. I want to call it 1990. That's the problem. But in 1990, remember, routers could only do like 1.4 megs of throughput. So it didn't matter if we had a 10 megabit fast Ethernet port. We couldn't do it anyway. So that kind of puts them into your context what they were. Now, let's talk about the other way we could do router on a stick that wouldn't be so bad. Now, what we'll be able to do is we can actually bundle multiple links together and make them look like one, so we don't have to deal with that stupid spanning tree, because spanning tree is a disaster. So we can bundle all these together and it's going to look like a link, and we won't have anything blocking. It's all going to be good, good, good. So now with this, let's say this is 4, and this is called ether channel. People also call it like a link aggregation group. But what if we have over here, if we have 4 100 gig links going from a layer 2 switch to a high performance router. Now, if we've got 400 gigs and this router can do 400 gigs, guess what? Now that router on a stick is cool. But how many people are setting up 100 gig links in ether channel or link aggregation group to use router on a stick? No one, because they would never be involved in doing this when they can buy this, and they've been buying this for the last 20 years. So I worked for a switching company a while back, and 20 years ago, I'm in the switch, or 20 some years ago, I'm in the switching company, and they're like, Mike, look at all this cool bridging stuff we can do. And I said, yep. Look at all this cool routing stuff the switch could do. And they'd say, Mike, routing's too complicated. People don't understand it. And I said, I'm going to train them because I don't want anybody dealing with bridging loops. And they would push bridging loops, push bridging. I would push routing. And my customers never really had any problems. And it wasn't that the other bridging people weren't smart. They were geniuses. And bridging is fine, but there's so much that can go wrong. IP is just so much easier. We don't have to deal with it. So kind of keep that in the back of your mind. So now let's look at it. Looks like the Cisco way. Let me show you the way the kind of way that it would look like. So here, what we have here is this thing that looks like that's using the router symbol is actually a switch. So what happens is the switch now has VLANs in it, it has VLANs in it, and there's a router module in the switch, just like I drew. So why does this look like a router? Well, switches don't do layer 3. So once you start having a layer 3 switch, we routing people call them routers, even though they're technically layer 3 switches. So what's it going to look like on a configuration side? I would have done this with you today, but apparently my EVE-ENG server after the power outage is not happy. I'll have to invite my master breaker and troubleshooter. She'll come in, she'll lick her paws, clean her hair, she'll start chewing through some cables, and hopefully she can fix it for me. I'll hire Cindy the cat. So, but this is what you're going to do on your device. You're going to actually enable routing by turning on IP routing, and then you're going to put an IP address for the VLAN. And then you'll be able to see it. So you put an IP address in the VLAN, enable your VLANs, and then you're going to look in your routing tables. And you know what you're going to see? You're going to see that your VLANs are actually connected. You're going to see that we've got this stuff connected and where they're at. So just like any other routed interface. So let's talk about how we would troubleshoot VLANs if they don't work. Because, well, we have to make sure the VLANs are up, right? The switches, remember how we had them port shut down and they didn't work? we have to make sure that our routing is right, our IP addresses are right, etc., etc., etc. So when something doesn't work, what do we do? Where do we look for? We look for the following. Look at the routing table. The routing table is going to tell us what's going on. If I do a show IP route here, oh, there's no routes. That's not good. Why wouldn't there be any routes? Because it's configured as a layer 2 switch. How do we turn on layer 3 switching? With the command IP routing. So as you can see, we're getting through this. It's really not that big of a deal. When we want the switches to be routers, they have to be a layer 3 switch, and we have to say, yes, you can do this. So let's do a little bit more debugging and some graphics. Going back here, if we look and notice that something's wrong, we're going to configure it. So let's look right now at this interface fast Ethernet 0/1. Will it work? Why won't it work? Interface fast Ethernet 0/1 shut down. Okay, well, that's not going to work. Why is it not going to work? It's not going to work for the following reasons. It's shut down. Admin down. So if we do a no shutdown, it'll come up. We don't know that until we look in the configuration. We can do a show run, which will show running-config, which will give us the running configuration, etc., etc. As we can see here, we have the interface. It's shut down, and that's why it's going down. So let's play with it a little bit more. No, we can, in certain cases, we can turn a switch port into on a layer 3 switch, we can create a VLAN and say ports 1 through 10 are part of this VLAN, and it's going to work beautifully. Or what we could do is we could take a layer 3 switch and just put an IP address on a port. Remember we did that yesterday? So normally speaking, what we would do is we would say, for normal things, we'd create an interface for the VLAN, which would have the IP address. And we would add the ports to the VLAN like you saw me do yesterday. In this particular case, interface gigabit Ethernet 0/1, we have to tell it not to be a switch port, to be a router port, and then we put an IP address on it, and then it'll work. Let me just walk you through this. So let's say we had a switch. We wanted to turn on routing. We would turn on routing. We would put an interface on the VLANs, which have the ports. As long as they're one port up in a VLAN, it's going to be up. But if we wanted to take a single port or a single interface on this device and get us there, we absolutely can do it by basically putting a port on the interface. But it's also doing one more thing that we have to do. It's an issue of just making sure that, what's the word I'm looking for? Okay, I have a feeling I know where our stuff is. So keep that in the back of your mind. Let's go through this. Let's go back to the show interfaces command that we have. Over here, what we can see that the port is up, right? How can we tell? Well, it says show interfaces gigabit 0/1, gigabit Ethernet 0/1 is up. Okay, that means you've turned it on, and it's got link or wires plug-in. Line protocol is up, meaning it's formed a data link connection. Now, if we do a show interface status, look what we can see. We can see which ports are connected and which VLANs they're in, and at what speed. And of course, we can show that on the routing table. Next over here, implementing routing interfaces on switches. Basically, it's the same thing, what we're doing. Now, I'd like to describe Ether channel to you. And Ether channel is a very old technology, and it works absolutely great. If any of you guys desire to do any work in the cloud computing community, guess what? There's a new version of Ether channel, and it's called a link aggregation group. So what is a link aggregation group, and why do we use it? So if you'll recall, when we did switching, And I'm going to, in case you missed it, I'm going to talk about it one more time. I'll actually draw a little picture and then we'll go back to this. So imagine this. You've got a switch over here, SW, and you've got a switch over here. 2 switches. Now we have 2 links between the switches. And we've disabled spanning tree, which blocks loops. So here we go. We got a PC over here. Let's take a box. Create a PC over here. Let's say this is Cindy. Cindy the cat. Cindy's PC. And over here, we've got this cat named Noni. It's one of the Blue Wrenches, Abigail. She's got a beautiful cat. So over there, we've got Noni that's sitting on the other end. And Cindy decides that she wants to send Noni a picture of a rat. In this particular situation, what we would have is we'd have Cindy sending Arp, who has the MAC address for my best friend Noni. And then Cindy's request would go out this port and this port. Because and what would happen is it would get flooded out this port. But what would also happen is this switch would then send it out all ports, which would go to this switch. And this switch would send it to this switch. And what's going to happen is we're going to have this packet replicated forever going this way and another one going this way until it fills up the link in a broadcast storm. So what we had was spanning tree that would block this link and say, woohoo, I'm sending my information. It's going to go over here, 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 and here. My communication is going to go back here, here, and here, 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 and here, 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 and here. All kinds of good stuff. All kinds of good stuff. So because of this, what we're actually talking about is, these are the kind of stuff that we're talking about. So now, so what we know is spanning tree as follows. Spanning tree, for example, spanning tree of loop avoidance. The spanning tree will block one of these links. Now, that's great. But what if we didn't want it to? What if we wanted to have 2 links that worked? Now, what if we could take 2 links and make them together like one big link? What if we could bundle these 2 links into a big, thick link? So we've got 4 10-gig links together. Now, if the 4 10-gig links are together and one of these 4 links fails, guess what? We've got 3 more in there. 3 more in there. So as follows. Cindy wants to send something to her friend Noni. Arp, who has the MAC address. The switch forwards it out. All ports except the one it came in on. It goes out to Noni. Noni sends it back. It goes back to Cindy. Now Cindy's sending her a picture of the squirrel she caught. Noni's sending her a picture of her favorite tuna. Cindy's then sending her a picture of her ball. Noni's then sending her a picture of her cat tree. Cindy's sending the picture of the cat tree that her father spent $500 on building that she saw and she walked out of the house. And Noni says, that's a shame. I would have loved that cat tree. It's a shame you made your father throw it out. And the 2 of them are communicating, and they're communicating as life is good. We don't have to block any links because they only look like one link, even though there are 4 links bundled together. That's called ether channel. That's called a link aggregation group. That is awesome. 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 So now let's walk through something that looks a little more official, and I'll show you an example. Here's what we're doing over here. We're going to just show interfaces port channel, and here's what we're going to see. We're going to see the line protocol is up. We're going to see what the hardware is, for example. We're going to get a show interfaces status, and we're going to pretty much figure this out. So we can see which ports are there. Look, there's a couple ports in here. Isn't it great? They're all connected. Fast. See, it calls it port channel. So it looks like one link, even though it's more. That logical doing things, that speed, that performance. So let's look at a little more details. we're going to show an ether channel summary at layer 2. We're going to see that it's bundled. We're going to see what layers we're using, et cetera, et cetera. So this is some pretty cool stuff. So with anything else, if it doesn't work, we got to troubleshoot, and we're going to keep it there. So here's what we're going to do. I have an idea where I think my server went, and I'd like to get it back online, but I'm not sure if I can. So what I'm going to try and do is check my firewall, see if I can find the main VMware ESXi server, and come back to this. And if I can't, don't worry, we will have some fun. So Chris, while I'm going through this, if you could look through some questions and potentially see if they have look through some of these questions, and then what's the word I'm looking for? I'll answer some of them.
Yeah, I'll have questions ready for you when you're ready for them.
Yeah, just bear with me for a second. I have a theory that what happened is after my system came back, the system rebooted, but the virtual machine that was inside of the system didn't come back on. And I think that could actually be the case where if I just go to the VMware ESXi server and turn the lab back on, everybody will be good. So I just want to see if I can actually do that. And if I can't do it, no big deal. We know that it's not done. Okay, 116 is my PC. 11 is not it. Well, you know what? It could be. Let me try 125, then 11, and then 115. I want to try and find out which one of these servers it is to see if I can get back and do some more labs with you guys. Okay, so, I think we found out where our server went. So while you're doing that, I'm rebooting that server, the virtual machine, and hopefully that's going to get us up. And in the meantime, Chris, if you want to bring me a couple of questions, I'd be thrilled to answer it. Chris, if you can have those other people trying to work on that, and we'll make sure that we close by 3 o'clock today. And if you can please inform Mark between 3 and 4, we'll get him a response. With a layer 3 switch, you don't need a router. Exactly. A layer 3 switch is a switch with that little router module inside of there. Exactly. Albert, are switch virtual configuration possible on layer 2? No. It's a router thing. This is a layer 3 switch thing. So on a layer 2 switch like this, absolutely not. The rest of the layer 3 switches in my house, absolutely yes. Good question. You know, that's kind of the thing. So where this came from, Angelo, is as follows. It used to be that switches were fast and routers were slow. So we switched everything. So when I started and I did my CCNA, I spent about $6,000 for a Cisco router that was called the 2500 series router that could pass 1.5 megabytes of traffic. You heard me. I spent $6,000 for a router that could pass 1.5 megabytes of traffic. At the same time, Cisco was selling the Catalyst 5000 switch that could come close to like a gigabit of throughput compared to the 1.5 megs. So, you know, that kind of put it into context of exactly, and maybe it was a half a gig, but it showed you how fast switches were versus how slow routers were. Then fully programmable ASICs came out, and then ASICs came out, and now we have routers that can push a terabit a second of data, like nothing. So when we're dealing with that kind of traffic, what happened was we started switching because it was fast. And then this concept of the router on the stick was kind of the stupidest idea we ever had, but it was the only idea we had. So by popping that router in there and not creating all those sub interfaces and bandwidth problems, we called it a layer 3 switch. The term actually came, I believe, from Extreme Networks about 20 years ago. I was using their switches. They were fast as can be. And then everybody else copied them. How does a link aggregation group prevent a broadcast storm? Like this. So if you have a link aggregation group, you've got one wire no matter how many you have. If you don't have a link aggregation group, it looks like you got multiple. And you have packets that can loop and loop and loop in a circle. But you can't loop if you only have one. That's how a link aggregation group prevents it. So in spanning tree, you block one link. With a link aggregation group, you only have one link. There may be 4 bundled in the link. So think of a link aggregation group as a sports team. You get on your team and there's 4 people playing podosfero. I think it's called football in Europe and Americans call it soccer. So they're all a team. You only see one, and that's what's going on here. There's always at least 2 switches. 1 is none, 2 is 1, and 3 is greater than 2. Switches, yes. And the link, I was just showing a link aggregation group, exactly. Also called port channel, ether channel. Exactly. Does a smart switch have an IP address? You have to manage it. And how do you manage things? Via SSH or Telnet or HTTPS, et cetera, et cetera. And that mandates that it has an IP address. And yes, that is a great question. What accounts for switches being faster than routers? Well, now they're not, but routers used to do this. Packet would come in, the router would look at it and would say, source address, destination address. Let me send that packet to the CPU. The CPU in those days, which was 25 megahertz and had 8 megs of RAM, the CPU would look at the packet and then forward it, and then forward it out. Look at the packet and then forward it out. Look at the packet and then forward it out. So here's the thing. CPUs are slow. You can go out there and buy the biggest, baddest AMD EPYC server with 128 cores and 4 terabytes of DRAM. And if you want to mine Bitcoin with it, guess what? You'll spend $5 a day on this system, burning electric, and you'll make 30 cents a day in terms of Bitcoin, because that's how slow CPUs are. Now, you pop 10 GPUs in this system. Graphics processors have much more power processing. Now, GPUs are now running a SHA-256 hashing algorithm. And guess what? With your 8 GPUs, which you have, which is really, really, really great. Fantastic, your 8 GPUs. Guess what? Now you're generating $2 a day of Bitcoin and spending $15 on electric. Now you go to Bitmain and you say, I want ASICs, which is now what switches use. They use ASICs. And instead of being able to generate $2 a day and spending $5 a day, they have a machine as cheap as can be. I mean, it's got like $30 of ASICs in there and a Raspberry Pi. You plug this thing in there and it's hardware. This thing can compute like 200 terahashes a second. It's extremely. This thing generates $30 a day and uses $1 a day of electric. So the point is, switches went from CPU to ASICs, and ASICs are lightning fast. So now you kind of get it. Look, I love AMD EPYC servers. I'm actually using my AMD Threadripper Pro 64-core workstation with a 0.5 terabyte of RAM and a Quadro A6000 card just to be streaming at you right now. And guess what? These challenges still have their problems. So, there's that. Now, Chris, you want to bring in the next one? Robert, everybody calls it a trunk. The term trunk came from actually voice as a trunk port. Link aggregation is extremely different than a trunk. Link aggregation is when you bundle multiple links together. A trunk port is when you put multiple VLANs on a single wire. Now, what you might be confusing is, in many cases, what we do is we create a link aggregation group and then turn that into a trunk. So it goes back to that same problem I was trying to tell you before, with regards to, the router and the stick being like one of the worst ideas we had. And here's the reason. Let me just create a new slide. A trunk is anytime you push more than one VLAN. So you got a switch here. That's the wrong one. Never mind. So we've got a switch here. It's got 10 VLANs. We got another switch, which has 10 VLANs. Now we got one wire between them. It's a trunk port. Always, whether you're in a Juniper router, a Cisco switcher router, all of them, it's always called the trunk port. Now, what we can do is we can bundle multiple trunk ports together, and we can create like 3 or 4 of these together, and that's what's called a link aggregation group. We put multiple wires, and so now what we have is a link aggregation group. And all a link aggregation group is, we have multiple wires together looking as one, but Now, what we have to do is we can create that, but we still have to turn that into a trunk. And the trunk is what happens when you put more VLANs. So you can have a trunk port that's also a link aggregation group, or you don't have to. You could just have a link aggregation group that just bundles 10 gigabit Ethernets for a single VLAN for speed. But if you ever want to push more than a single VLAN, then what you have to do is as follows. If you ever want to push more than a single VLAN, you need a trunk. So you can have a link aggregation group, which is just multiple bundled links, or you could have a trunk on a single link, or you can have a trunk on a link aggregation group. That's really what we're talking about. That's exactly what we're talking about. Okay, so if any of you want to kind of see how we would configure some of these things, let's play with it. We're going to create a new little mini lab over here. Warning, select time to rename. All right, we'll figure it out. So let's go back to EVENG, which should be coming up right now. I'll work on it. We're almost there. Bear with me. Okay, we are up. We are running. We got our routers back and running. Our labs up and running. Apologies. It's really hard to give a presentation in front of an incredibly large number of people, and at the same time, to let you guys know, we're gonna finish around 2:30 today. We're gonna head back up on Tuesday. There's some critical advice some critical things that need our attention, but we will go long and strong next week, and it will be a ton of fun. So let's make sure we have some fun over here. Let's get involved in some of the things that we're doing, and let's have some fun with it. So let's create some routers. We'll create a couple of static routes. What do you mean? So base lab. Let's have some fun. We're going to enjoy ourselves. And in this class, if any of my disciples are on this call and you actually got the message from Chris, if you're able to assist, that's great. If not, totally understand. So over here, what we have, we're gonna have another Cisco router. Let's make 2 of them. Let's make 3 of them. Since there's a little bit of a confusion on the static routes, the dynamic routes, on why we're doing what we're doing, so let's have a little bit of fun. We'll plan on it. Heck, if you want, we can even create a router on a stick. Let's do that. Let's do this. Let's do a little bit of routing, and if we have time, we'll create some routing on a stick. So let's create a wire between these 2. Let's create that's perfect. Let's create a wire between these 2. Perfect. Let's boot up our routers. And while we're doing this, everybody, if you can type #CCNA while our routers are booting, then we're going to have some fun. And I'm always in for fun. Fun's always good. No problems about fun stuff. Let's add a switch while we're at it if we have time to do it. If not, I'll be doing some switching stuff with you. And while we're at it, let's add another link. We'll add a link between this page. Okay, so now we've got some devices, and let's have some fun. Let's just turn them all on, since hopefully we can do some really cool lab stuff today. Start. Debugging and troubleshooting while presenting. I must say, this is cool. So while we're here, let's do this. Oops, that was not what I meant to do. Okay, thankfully this is here. So let's get into our first router. We'll press enter. You guys are going to tell me in the, I want you guys to actually tell me in the chat box, what are going to be my next classes. So I want to go configure this router, my first router over here, right? It's coming up. We got to configure it. So I want you guys to help me. So everybody in the box, are we going to use this ridiculous initial configuration dialog? Yes or no? Why? Because we want to set it up the way we want to set it up. So So let's talk about what that actually means, setting it up the way we want to set it up. Okay, our device is coming up, coming up, coming up, coming up. Life's good, it's coming up. Okay, it says router. So should we leave it router or should we make sure we don't get lost? Not sure what's going on here. So, okay, you can see me again. So, okay, so not really sure what happened over there, but all is good. So now we're over here. We're in this particular position, and our device is up. So what should we put over here? And we should configure this thing, right? Should we put a host name on it so we know what it is? Let's call it router 1. We create a loopback address so we can find this. Loopback 0, of course. Let's give it an IP address. Let's call it 1.1.1.1. That is, everybody, a /32. Okay, we're going to do a no shut on this. Now, what kind of an interface do you think we should use for our WAN link? How many IP addresses could be used here? How many are possible in a subnet? 2, right? 1 on each side. So let's do this. Let's go to interface, gigabit int G0/0. Let's come up with another subnet. Let's use the 192.168.1.1, 255.255.255.252. We didn't put an IP address. So how do we get to the beginning of the line, everybody? Control A. Control A gets us to the beginning of the line, and we type IP ADR for address, and poof, let's turn the link up. No shutdown. Okay, config T, line VTY 0/4. This way we can tell them this. Let's create a exit. Let's put an enable password. Cisco. All right, we're good. Router 1's all configured. So what kind of interfaces do we have on this? Okay, as we can see, we've got our gigabit Ethernet port, which is up. And we've got our loopback address, which is up. So good stuff, huh? Now let's go over here. Let's go to router 2. Let's make this router 2 work. Now router 2's got a couple of interfaces on it. So it's asking us, everybody let me know, #CCNA in the box if you're having fun. So it's saying, should we enter the initial configuration dialog? No, we shouldn't. So let's type no. Chris Leo may be a bit of help in that short time. So let's configure this thing. So we got to get to enable mode, right? So how do we configure? We type config T. Now, on the last one, we'll name it pizza because I saw Ruben came up with the host name pizza, and I think that's kind of perfect. So let's do this. We're going to create a loopback address on here for management, L00. We'll create 2.2. Let me give it a nice IP address. 2.2.2.2. I probably should tell the IP ADDR. 2.2.2.2. 255.255.255.255.255. No shut. Now let's look at the Ethernet interface that goes back to our last one. That's G0/0, G0/0. Now, what's this IP address on this /30? 192.168.1.2/30. So, /30. 192.168.1.0 used by the network, 192.168.1.1 used by the systems, and then we have 192.168.1.2 So let's pop that on there. Config D. We don't need to do this. We just should go to interface G0/0. Put an IP address on it. 192.168.1.2, 255.255.255.252. No shutdown. Now we also have an interface that's going to be pointing to router 3 over here. It's G01. We should probably just use the next subnet, right? So let's use the next subnet. So in this particular subnet, we're going to go to, I already forgot the name of the interface. This is good if you remember the interfaces. So we're going to go to interface G0/1. Then what we'll do, we'll put that in IP, we'll give it an IP address on the next subnet. That should be 192.168.1.5, 255.255.255.252. No shutdown. Line VTY. Sure. Now, what you should do whenever you're finished, you make a configuration. For the exam question answer is, how do you take the running configuration and copy it to the startup? The exam answer is copy. I'll show you right over here. We probably should put a host name on it too. So when you want to save this, you could do, this is the official one, copy running -config to startup -config. That is your test answer. Copy running config to startup config. Destination, yes. And it's going to save it for you. Okay, so we've copied it to the running configuration. Now we should be able to ping across the link, right? We should be able to reach 192.168.1.1. Might we lose one? Ping. Bang, 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 bang. Okay, we lost that one. Everybody, why did we lose that first ping? What is that obnoxious screaming? Who has the MAC address for this thing? What's that called? Everybody pop it in the chat box. Alexandra Polikalo, ima polia menos, which means Alexander, great job. I'm extremely happy. He just happens to speak Greek and he's here, so why not? So, excellent, excellent. It's in the Arp cache. That's the problem. Arp, we lost one due to Arp. So now let's go to our third router along the line because this is cool stuff. We want everything to be awesome, right? Let's go to our third router. Now, I heard a really creative suggestion for the host name. No, we're not going to enter this ridiculous automatic thing. Of course not. We want to do it ourselves. We want it to work. Okay, we're having fun. All's good. Good, 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 good. Okay, so now we're waiting for the slow router to turn itself on. And now you know why switches are fast and routers are slow. Okay, you can see it. Okay, enable. Let's go to the configuration mode. Let's change the host name. I saw the most creative one, PIZZA. People like pizza. We eat pizza in Greece. People eat pizza in people in Italy, South America, US, everywhere. People eat pizza. So let's say the host name is pizza. Okay, let's create a loopback on this. So interface loopback 0, IP ADDR 3.3.3.3, 255.255.255.252. Oops, that was the wrong GA. Nope, that was the wrong subnet mask. So let's see. Show. Let's see if I overrode it. Show run int L00. Okay, we got the right one. Good. Big P. Now let's go over here. Now we're over here. We got this gigabit Ethernet 0/0, right? Int G0/0. P DDR. Now remember what's it on the router 2? On the connection link? Show, because it's got to be on the same subnet, right? Show IP int brief. Okay, so over here, what are we seeing? What are we seeing, everybody? we're seeing that we needed to be the next one in the same subnet. Well, if we previously had 192.168.1.5, and the subnet goes 192.168.1.4 for the network, and then we've got 5 and 6 as usable addresses, and the broadcast is .7. Now we know what address goes here. Now while we're at it, let's create another loopback. We can generate some routes. Okay, so let's look at the interfaces on this. You guys are all going to know routing by the end. Let's ping across this link. Might we lose one ping across this link? And if so, why? Again, pop it in the chat box. You guys got it last time, so I'm pretty excited. So let's see, 192.168.1.5. Lost? Bang, 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 bang. And that's what that little exclamation point is called. It's called a bang. So all of it. So now let's look at the routing tables on this one. Show IP route on this one. It's got our locally connected stuff. Now we got router 2. Let's look at the routing table on this one. Now let's look at the routing table on this one. Note, what are all the routes? Excellent, Chris. What are all the routes over here? The routes are as follows. Show IP route. All these routes on these devices say C or directly connected. So here we're on pizza. This guy has a 1.1.1. Can we ping it? Of course we can't. Why can't we ping 1.1.1.1 from 3.3.3.3? What does 3.3.3. know? What doesn't it know? It doesn't know how to reach 1.1.1.1. So what if we did this? Let's go to router 2. Can router 2 ping 1.1.1.1? Of course not. Why not? Why can't we ping 1.1.1? Albert, you got it. We don't have a route. We don't have a route. So if we go to router 2 and type config t, IP route 1.1.1.1, .0.0.0 with the next hop of 192.168.1.1. Oops, sorry, I got the mask wrong. Now, look at the routing table. Now we have a route to it. The question is, do we have a route back? Let's try it. Ping 1.1.1.1. We can reach it. Why? We have a route. That's all it took was a route. So if we're on router 2 and we want a path to 4.4, we could do this. We could do IP route 4.4.4.4 255.255.255.255. Pick the next hop. What's the next hop on this device? It is going to be .6, 192.168.2.6. Oops, wrong subnet. That's not going to work. So let's do this. Control A. And take us to the beginning. Let's get rid of that line. Why isn't it going to work? It's on the wrong subnet that I gave it the next hop. It should be 1.6. Let's make sure that's the address that's sitting on this router. 1.6 it is. Oh. Can we reach it now? Yeah, because we have a root. So when we deal with this, it's this. Now, what happens if anything breaks? Is a static route going to reroute against it? Is it going to self-heal? No. The reason I try not to use static routes is as following. You see how these routes are here via static? So now I want you to see something. See this 1? That's the administrative distance or how believable the root is. So the router figures this to be pretty good. So let's get rid of that. Now, let's actually do that. Let's look at the actual routes in here. We're going to get rid of the static routes. So we'll do this. We'll do a config t. We'll do a no, and then we'll copy this in. And then we'll do a no, and then we'll copy this in. So what could we do instead? We could use dynamic routing. Anybody have a favorite dynamic routing protocol they'd like to use for right now? We'll probably should start with an interior gateway protocol, and we'll work our way up through exterior gateway protocols. You guys like OSPF? You guys like EIGRP? What is it you guys love? Okay, so now let's use this. Let's use EIGRP. Router EIGRP1. That work? 3.3.3.3. Network 4.4.4.4. Actually, no, let's just do 4.0.0.0. Yeah, let's just do 4.4.4. We'll have to play and see if I configured our EIGRP right. Because you know when the last time I used EIGRP was? About 20 years ago. I think I did it, was playing with it the other day just for fun. See if I did it right. If not, we'll switch it to OSPF1. See if it worked. If we got any routes. Okay, so now look at this. When you look in the routing table, you can see that 2.2 is directly connected to the router. You can see that 3.3 is learned here. Now, when you look at 3.3, you see this thing that says 90. Now, that's what Cisco calls the intermediate distance. So 90 is a number. The lower this number, the administrative distance, the more the route is believable. Now, this is the actual cost to reach it. So now, do you think we can reach it? Can we ping we should be able to ping anything in the routing table. So 3.3.3.3. We reach 4.4.4? We can, because we have a path. So if I didn't give you a route, so let's go back to this routing protocol, and let's just show you how easily we can secure this device. So let's do a show run EIGRP. Look at our routing configuration over here. Note, I advertised 3.3.3.3. And realistically speaking, I didn't even tell it to not do an auto summary. Realistically speaking, I normally would. And the reason I didn't is in this particular version of iOS, it's still showing us the first thing. It's no longer summarizing by classful boundaries like it would have 20 years ago. Otherwise, I would have had to type no auto summary, or technically no auto dash summary. But I didn't need to do that because the default is not to do that behavior. So let's go to router EIGRP1. Let's do a no network. Now, I just removed, everybody, the BGP or the EIGRP for the 3.x network. Are we going to see it over here? Let's see. See if we can reach the 3. Oh, it's not there. Can we ping it now? Can't ping it. Okay, so look at this. Just look at this. We literally speaking, were able to make it that you couldn't reach anything by removing a route. Now, when it comes to security, firewall, good. IDS IPS system, good. Access control list, good. No route, can't reach it. So, if you realize exactly how much we can do on the routing side. So now let's go to router 1. And what heck, while we're at it, let's do router EIGRP1. And now we've got our router EIGRP1. Let's put network 1.1.1.1. Let's also talk about, let's add the 192.168, 192.168.1.0. That was fast. Look at that. We can see the 1.1, the 2.2, and the 4.4. Where is 4.4? 4.4 is actually over here. So what? Let me show you what's going on. Let's have some real fun with this. Let's go to route. Let's go to this one. Don't do this in production. We're going to do a debug IP packet. Over here, we're going to ping that 4.4.4, the 3.3 that we can, or 4.4 rather. Oh, I probably should have enabled that. Okay, so what are we saying? What are we looking for with this? We can see that the source here reached here. So we can see it going through. No debug. Now let's go to the router in the middle, R2. Let's do a debug IP packet on here. Watch what it does. Now over here, I'm going to ping the same 4.4. But what's going on? Let's watch. So right now, what are you saying? 224.0.0.10, that's EIGRP messages, EIGRP messages. Now I'm going to send an ICMP echo through this router. Oh, it would actually help if I left the oh, that's, no, I don't want to run this one, sorry. I wanted to go to the middle router. Okay, so let's do it again one more time. Not on this one. Okay, so what do we see? We can see, wow, we can see the 1.1. You know what, it was too fast. There you go. See what, no, you know what? Shut that off before we go nuts. So you can see what's going on. Now, let's pretend we could use another routing protocol. So let's just say over here. Now I want you to look at this. So when we get to router 3, which is called pizza, Now look at the routes on this routing table. Note what you see. You see connected, learned via EIGRP, etc. What if, for example, we had a route that we didn't want to inject, that we redistributed from another routing protocol? So redistribution is like translation. So I call Ivadoikia. Ivadoikia's native language is Bulgarian, whereas mine is Greek. So, it's generally best to speak to someone in their own language. So, you just got to keep that in the back of your mind. So, but if I really wanted something that she spoke in Hungarian or Bulgarian or all the amazing languages that Ivadoikia speaks, in order for me to understand a language that's not Greek or English, I need a translator. So keep that in the back of your mind. I need that translator. So we can translate between routing protocols. So let's do a show running config. Let's look on running config on here. And what I can do is I can actually take information from one routing protocol and integrate it. So if I did this, if I do a config fig t, and let's just say I went to router EIGRP1, here, what could I do? I could basically take a connected interface. You have to, whenever you take the information from one routing protocol to another, you have to tell it the metric. Now what are we going to see? I just took that redistribute connected. Now if we go back to this router and I look at it, oh wait, now I see the 3.3.3.3. It says D, but it says something called EX. That means externally learned or translated. So Ivadoikia's native Bulgarian got translated into Greek, and we're now sharing some feta cheese, and we're happy as can be. Now let's look at this route a little more. Let's look at where it says 170 over here. That's the new administrative distance, and here's the new metric. So let's take some questions for about 10 minutes, and we are going to reconvene on Tuesday and have a networking party. Have a networking party. So let's do this. Let's let me find StreamYard real quick, Chris, because I've been in about 6 different browsers. Mike, how does an interior gateway protocol function from an exterior gateway protocol? So Angela, there's a lot of things. Exterior gateway protocols, you have to manually define the neighbors, and they're slow, really slow to converge around a failure, and they're designed to take in millions and millions and millions of routes. Now, an interior gateway protocol like EIGRP, how fast was it? The second I did redistribute connected, 2 routers away, I had a route to it. So interior gateway protocols are designed to be fast, 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 where exterior gateway protocols are designed to be scalable, scalable, scalable. Awesome question. Chris, bring in the next one. I mentioned the wait. Well, actually, I don't want to use wait, and I didn't use wait. The only time I will ever use the term wait is because it's a BGP parameter. What I did use is believability or the trustworthiness, and I used the term administrative distance. So administrative distance is how believable a route is according to what you've told the routers, or if you're using the defaults, what Cisco told the router. So Cisco will say eBGP or exterior BGP is more believable than EIGRP, and EIGRP is more believable than OSPF, et cetera, et cetera. So good question. You have yet to take the lesson for EIGRP. Maybe what you ask what the syntax is, the same as it is for every other routing protocol. The reality is if you do the CCNP or the CCIE, they will definitely make you deal with some of the EIGRP routing protocols. So I like to use a little bit of that when I teach these classes, because there's more than just certification which goes into getting hard. In fact, certification, I will tell you, is the least important part of getting hard. What it is knowledge, enthusiasm, attitude, communication skills, etc. So I'm trying to give you the more knowledge in case they ask you something on an interview. What is the practical use of a loopback interface? So if I were to remote access an Ethernet port and the cable goes down, I wouldn't be able to access the Ethernet port because it would go down and the IP address would go down. So we create a loopback interface to be the router identifier. Remember, OSPF and BGP have router identifiers, which is based upon the loopback address. So it's an address. If we've got 10 links to a device and 9 of the links fail, we can still reach the loopback because it never goes down. That's logical. So it's management. Why do we assign a /32? Because we only have one host. So if we do /32s, I can create basically 255 out of a single class C network. Very efficient for IP use. Good question, though. How can you relate this to cloud routing? It's 100% identical, Chi. Nothing's different. Everything is the same, 100%. So if you don't understand this, nobody understands cloud routing because routing goes to the next subnet based upon routing tables. It's identical. Chris, you want to bring in the next one? What bearing does cost have? The cost is how hard it is for you to get somewhere. So if this link costs $1 million and this link costs 1,000, I'm taking the link that costs 1,000. That's just how ugly it is to get there. But the question, let me go back to that last question about how does this routing relate to cloud routing? And I said it's identical. That's why people that have 10 AWS certifications still can't get hired as a cloud architect unless they know the network at the data center, because this that we're talking about right now is identical to the cloud, and it is never, never, never by any stretch of the imaginations it covered in any of the type of cloud computing certifications. Even the advanced networking doesn't cover any networking. It's honestly, it's like an intro to an intro to an intro to an associate network, of course. Linux Charmer, why are so many ISPs using intermediate systems to intermediate systems over ISPF when picking the two? Actually, Linux, that's not exactly true. I will tell you that, say, CenturyLink in the US is using it. And I will tell you, of all the ISPs that I've designed, I've dealt with 2 that were using intermediate systems to intermediate systems compared to the other 11 that were actually using OSPF. Why are some of them using intermediate systems to intermediate systems? So when we're dealing with a link state routing protocol, specifically for MPLS, what we need as much data as possible. And when we use OSPF, we kind of need to use a single area. Or with intermediate systems to intermediate systems, we need to be in that single area because we're looking for the maximum amount of information in our LSAs, and in between areas we don't lose it. As it stands, intermediate systems to intermediate systems, which is really designed for CLNS routing about 2.5 decades ago, scales really well in a single area. So for that reason, because nobody in their right mind would ever design a single area link state routing protocol, until MPLS came along, then we needed all this extra information. Many of us have used this 30, 40-year-old routing protocol because it's really good at carrying information and it scales well. But most are still using OSPF. Angela, these classes are so useful. Thanks so much for taking your time to share your experience and expertise. I'm so thankful to be able to be here with you.
There's not any more questions right now. So we'll see if anybody else comes in.
Okay, we've got about 4 more minutes until we have to go. Just to let you guys know, we have so much of an impact in the cloud computing space. We're so recognized for getting people hired. We're so recognized for understanding what's going on and cutting through the nonsense that, just every day, the media is reaching out for us. And apparently something major went in that one of the massive media people needs to speak to us. So apologies. These kind of things affect our lives every day. But, after being in the industry for 25 years, it's just the kind of thing where every single day, if there's a problem somewhere along the line, they're looking for people to help. And we're one of the people that are on everybody's list. So apologies. Just sometimes emergencies come over in life. General question, how long is the CCNA test? I think I did mine in about 60 minutes. But I would say it could be upwards of 3 hours. Will this be archived to the channel? Absolutely. We want you to come back and come back. But I love the dog, by the way. Very cute friend there. Any other questions for us? If not, we are so excited to see you next week. Honestly, it's an honor and a privilege to be able to talk to you all. I want you all to have the best networking careers, cloud computing careers, etc. And you know what really excites me? You guys were filling in the answers with the Arp caches, with the routes and the routing tables. You guys have been really doing swimmingly. So good to see you, Jeannie. Sanchin. Everybody do me a favor, type hashtag CCNA. Marjan, it's good to see you. Nikhil. Anya, love that. Sharon, loving the CCNA. Alex, CCNA. Fintech, CCNA. Albert, yes, CCNA, exactly. Sanchin, CCNA. Brian, thank you, Mike and Chris. We are happy to help CCNA. Jeannie, CCNA over there in Las Vegas. Robert Welch, CCNA. Sean Ford, CCNA. I love this. Ruben, CCNA. It's good to see you, Alexander. Always good to see you, Vidoike. Thank you for all your Blue Wrench work. 7 Series BMR, nice. Nitropan, good to see you. Reginald, oh, wow, I'm so happy to see you. Reginald, haven't seen you in a little while. So it's good to see you. And Faisal, fantastic. LM, thank you, CCNA. Reginald Duncan, CCNA. Basir, CCNA. And Anthony, fantastic, CCNA. Mark, it's wonderful to see you. And Nitropan, thank you for all you're doing. Eric, it's good to see you, CCNA. Mr. Gee, love that, CCNA. And thank you so much for thanking my team. They do so many things. Caroline, so good to see you. And Lennox, Carmel, good to see you. So nice to see you, Torty. And M. Thomas, CCNA. And Georgetta, CCNA, you are more than welcome. Wood, CCNA in Jamaica. Oh, that's a great place. Oh, that's going to make me, again, every time I hear Jamaica, it makes me think of making bammy and turmeric tea and either a curry or some jerk chicken tonight. Maybe some cauliflower, rice, and peas because I don't eat grains. Oh, that sounds just great. So everyone have a wonderful, wonderful day. Enjoy the weekend. Feel free to go back and rewatch things because I want you to become networking experts. And see you all again on Tuesday. Take care, everybody.